I think, okay, we're up and live. I'm just going to share the screen. What we'll do is it'll take me to my PowerPoint. There we go. All right, so with a bit of luck, this is going to completely share. It's a bit hard to see, isn't it? You okay with that? I don't know what else to do. Maybe if I turn these lights off here, is that better? All right, let's do that. Okay, so functional retinal processing. I've tried to summarize this content as best as I can, but what I think you should do is look at this textbook, Schwartz Visual Perception, because that really contains a lot more information. So if you feel you're getting confused, my suggestion would be to do the reading from that book. I'll see if I can put some of it up onto LMS for you without breaching the copyright as well. But there are quite a few of those textbooks of Schwartz in the library. It doesn't matter if you've got an outdated edition. This information doesn't really change. Okay, so yesterday we found that the retina's got these several different layers, and they all connect and communicate with one another through these synaptic connections. And the image that falls on the retina is analysed, travels down the visual pathway. We talked about that. Now, we haven't yet, but we're going to get to that next inquiry. And then eventually, once the image from the retina is transmitted down to the occipital lobe, then it's decoded. The information about what you're seeing is interpreted in other visual centres, which are outside of the occipital lobe. When we go and talk about visual pathway and we look at what the occipital lobe does, you'll see that it decodes information about which way lines are going, whether it's a circle, whether it's a square. That's the kind of information that the occipital lobe decodes. Use some more simple things like that. And then the interpretation of understanding what that line is or what that square is or what that shape is happens elsewhere. So it happens in other visual centres. But this is not for today, so we'll just keep moving on. So we're going to be finding out about basic retinal processing and fields of ganglion cells. And I think students get often quite confused about this, but I'll try, as I said, break it down because it is quite steps. So we will examine the receptive field characteristics of the major classes of retinal cells, and we'll be looking at how actually found out that this all works, and I'll be showing you a couple of videos as well. If I can start making things a little bit easier to understand, I'm going to use the cursor to point because this will hopefully translate into the recording today. So what we have here is an experiment, and this is how researchers how ganglion cells respond to light. So remember, the ganglion cells to the photoreceptors via the bipolar cells, and they transmit the neural image down the visual pathway. So the ganglion cells are the ones that make up the optic nerve. So they have a receptive field, and what this experiment is showing is that there's a monkey sitting there, and fovea, we're looking at the left eye here, is aligned to a particular point on the screen. So the monkey is staring at the screen, just as you are staring at the screen here. So this is the point that the monkey is looking at. The dot, this cursor's not there. Is it there? Oh, it's not there. So you can't see it on, oh, well, I'll just have to use I'll have to use the laser pointer for you guys because I don't, could you see it before? No. So if we have a look at the phobia, that's essentially the monkey's lined up, just like you guys are sitting there. It's sitting there and it's lined up against what's going on? Sorry. There we go, back to the monkey. All right, I'm not going to touch anything now because I'm cursed when it comes to this. Okay, so the monkey's looking at a point there, something, they've shown it something of interest, obviously, banana or whatever. It's looking at something anyway, interesting. And what they've done is they've placed an electrode next to the temple of the monkey, next to the where they think a ganglion cell is. What the scientists have done is they've shone a spot of light close to where they think that ganglion cell is, and that the electrode they can see whether there's an electrical signal being produced by that particular ganglion cell. So with these cells, what happens is that there's different type of arrangements of cells. You can have on-center, off-surround, or off-center, on-surround. And basically what that means is if the cell is round, if a light is shone on the very center there where the pluses are, that's an on-center cell, and the cell will be stimulated. If on the negative surround, nothing happens. Now, hard to explain that, so what I'm going to do is show you these videos of Hubel and Weasel's cat experiment. These guys were Nobel Prize winning scientists, and they pretty much discovered how to stimulate these ganglion cells. So hopefully this will work. Oh no, come on. I'm just trying to find an alternative way to find. Here we go. Okay, you ready? You have to listen. Hopefully it'll work.
Presented it with different visual images. When we started working,
Okay, it wouldn't be normal if technology worked perfectly for me. Try again.